Hi to everyone. School of Engineering, Department of Mechanical Engineering, online classes, Department Mechanical, final year, semester 7, subject Mechatronics, unit number 3. So last class we discussed about different kind of peripheral interface devices. Okay, that is a programmable peripheral interface, that is 8255, and keyboard interface and LED interface we discussed. So now we are going to discuss about a temperature control of system with 8085 monitoring process. Okay, we are going to monitor the temperature and we are going to control the temperature using the processor in the industrials. Okay, so let's see the temperature control system. So this is the concept of temperature control system which was used in the industry purpose. Okay, so that is, so in this control format we have um, more number of functional blocks like 8085 microprocessor and memory, that is RAM and ROM, then keyboard and display interface for input and output operations, then ADC and DAC, that is analog to digital converter and digital to analog converter, then amplifiers, then transducers, control signals, heaters, then coolers, or we have a multiple number of functional block like this. Okay, so now when we need to start the plant, so that is, okay, that is power plant. So that is, so this is the plant. We are going to control the temperature in the conditions. So that means we need to get the temperature value of the plant using the some transducers like a temperature sensor. So like that, for depend on the plant temperature level, because for more number of variations in the temperature, we need to use different kind of temperature sensors. So we are getting the data from the plant using the transducers. Okay, then that getting the value of the sensor will be very low, so we need to amplify the value. So it is mostly the analog value when given to the microprocessor. So we need to convert into digital because microprocessor don't know analog values. Okay, we need to convert the analog value into digital. So we are using the ADC. It is converts analog voltage into the some binary numbers. Then it is shared by the common 8-bit bus to the 8085 microprocessor. It is have a lookup table for analyzing the data. Okay, so already predefined values are stored in the 8085. So that is compared with the given value. Then so processed output value will be given to the again 8-bit bus. Then it is go to DAC. So DAC means we know that uh, digital to analog converter. Okay, that means we are giving the control signal to the some uh, devices, electrical devices. So we need to convert the digital value into the voltage. Okay, so we are using the digital to analog converter. Okay, this value also, it is a minimum value. So we are amplifying the value on analog value, then given to the control signal. So these signals produce the conditions with respect to the input value from the microprocessor. If temperature of the plant will be high means it will enable the cooler. If low means it will enable the heater. If temperature is normal in the prescribed condition means it is select the no operations. Okay, this is the closed loop temperature control of the some power plant or plant engineering. Okay, for keyboard we are giving the input value variable to the functional blocks, then display to show the status of the temperature control unit, whether temperature high, temperature low, like that it is indicates. So RAM and ROM, it is stored the multiple number of values of temperature in the particular time period. Okay, what are the variations, like it is stored the value, that is RAM and ROM we are used in the temperature system. So in this system we have used two kind of status. One is program, another one is hardware. Okay, program means it is a software and hardware. Okay, in software conditions we are using the flowchart for getting the values. Okay, we know that different kind of flowcharts available for the temperature control unit. Okay, let's see the one by one. First we will see the hardware. So that is we are using the transducer for the measurement of physical quantities. Transducers are used. They convert them electrical quantities. For measuring temperature, sensor like thermocouple, thermistor, sensistor can be used. So that is amplifier. So if the electrical signal from transistor is small, it cannot be visualized or processed. Hence, it is amplified using amplifiers. So ADC, the electrical signal from transducer is an analog signal which a microprocessor cannot process. Hence, an analog to digital converter is used. So DAC, the signal from microprocessor will be digital signal, which is going to control the analog elements like heater, cooler, etc. So for that, the device signal from the microprocessor has to be converted to analog to DAC. Okay, in 8085 we don't have input output ports, so we adding the 8255 peripheral interface. Already we discussed in the last class, that is 8255 is a port generating programmable peripheral interface. Yeah, got it. Yes. So that is 8255 is a programmable peripheral interface. It is having the some input output ports, port A, port B, and port C. Here we are using the 8255 for generating the ports instead of 8085. Okay, this is the interface between the ADC and DAC with the microprocessor conditions. Okay, so here we are using port A for data communication. Port C is for the control signal operations. So this is a process of flowchart, that is initialize the 8255 port as an input port, port C upper as an input port, and port lower as an output port. Okay, that means we are initialize the 8255. We know that the 825, when we go for 8255, we need to initialize the which port we are going to use the input output, which port we are going to use as the output port, like that. Okay, then second step, send SOC to the ADC, that is start of conversion. We need to set the start of conversion through the CL port. So check for the end of conversions, whether all the data are converted into digital, like that. So there is end of conversion from ADC. If no means, read the data from AD. Then store the temperature, digital voltage in memory location. So compare the analog digital to value with the memory locations. So display the equivalent values in degrees. So repeat the step 2 to 7 for continuous temperature measurement and control. This is the concept. Here we have lookup table. So for analog hex value, they are giving the inputs. If I receive 85 means the digital value will be 9 will send to the processor, then analyze. So this is the flow chart for temperature control. So that is start. That's already we seen that step by step. Okay, here start, initialize the 8255, then send SOC, then check a UOC. If no means it will again send SOC, then yes, read ADC A to D, then start store lookup table concepts, then check with the measured data. If yes means display the data, if no means increment the memory location, then again continuously with respect to the comparisons. So this is the assembly language program for executing the temperature controlled concept. So there is a memory location for program is 4000. So that is mnemonics. So first they initialize the value 8255 with the move immediately A comma 98. So 98 is the initial control word register concept. If I put 98 means port A as a port A as input port, port C lower as output, port C higher as input. These are the concept. Okay, this okay, this is the temperature controlled unit in the power plant. Okay, so only thing for different plant means, so some of the plants are working in the 0 to 20 degree. So we need to use the temperature sensor according to the conditions. Okay, this is the concept. Okay, if you are using a, if power plant working in the 400 degrees Celsius means we need to use different temperature sensors. Okay, this is the one concept we need to remember for the analyze the temperature control with the processor. Okay, okay, thank you. We will see in the next class.